This might be the qualifying exam. I'm not 100% sure, but let's go over it. So question number 1, this is a t-distribution table. In other words, the big numbers here, these are the critical t-values. What that means is when you run a t-test and you come up with a t-test statistic, your calculated t-test statistic, if it's less than these numbers here, right, these numbers, that means that the null was true and you do not reject the null. But if your calculated test statistic is bigger than these test statistics, then you would reject the null. These test statistics are called critical test statistics. So you're comparing your calculated test statistic to the critical test statistic. The table represents a one-tailed probability test. So let's go down and read the question. Which of the following t statistic results would be significant at the 0.05 level? But now she throws a curveball at you, two-tailed, for an independent sample t-test with 10 participants per group. All right, first of all, with two-tailed, what we got to do is we're not going to use the 0.05, we're going to divide it by 2, right? So remember, 0.05 for a one-tailed is either one side of that probability hump, right, the bell curve, or the other, where two-tailed is it cuts it in half. So this is going to be our column to look into. Now we got to calculate the degrees of freedom. So remember, the degrees of freedom are the number of total people. So she's got two groups with 10 people apiece. So 2 times 10 is 20 minus the number of groups. And an independent sample t-test has 2 groups. So 20 minus 2 is 18. So we're looking at this row and this column. So only those t-statistics that are greater than 2.101 are considered significant. And it could be a positive or negative. It doesn't really matter. We take the absolute value of this. So it looks like the only answer here that's true is D, right? D is the only one that is significant at this level. All right, number 2. We're doing this one. So we have a score of 85 from a test that has a mean of 100 and a standard deviation of 15. That's the first test. Second test is she mentions the t-score, capital T, not to be confused with the little t as in t-test. This is, I believe, from the MMPI, but it's a different test. That's what we have to realize. And so this score is what we have to find, the equivalent score on a t-score, but they give us the mean of 50 and a standard deviation of 10. So remember, these are 2 separate tests. So when you got 2 separate tests, you're basically, you're going to have to standardize the data, which means we're going to use a z-score formula. So a z-score is, right, that x sub I, that's the individual piece of data from a data set, minus the data set's mean, divided by the standard deviation, right? That's the formula we're going to use. So for the first one, the first test, the guy got 85, so his z-score is going to be 85 minus the mean of 100. That's our numerator. And divided by the standard deviation of 15, which comes out to be, what, negative 15 over positive 15, which looks like negative 1. So we need a z-score of negative 1 for the second test. So for the second test, I will change colors. Second test, we're going to calculate the z-score, and we're going to use the same formula. So we know what the z-score is. It's negative 1, right? So I'm going to substitute this z for negative 1 equals x sub I, that's what we're going to solve for, minus the mean, which is 50 in this problem, divided by the standard deviation. Now, we got an equal sign between 2 values. This is what I used to teach in my college algebra class. We're simply going to cross multiply, right? So cross multiply 1 on the bottom times xi minus 50. I'm just going to call that x from now on, equals x minus 50 has to equal negative 1 times 10 is negative 10. Do some algebra. We're going to add 50 to both sides. So our answer is going to be x equals 40. That's the answer here. And that's how you do those. Number 3. If the outcome of a test is significant at the 0.01 level, in other words, the critical alpha is 0.01, Which of the following are true? It will also be significant at the 0.05 level. Nope. Nope, 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 right? So significance has to be less than this number, right? So whatever your calculated p-value, your calculated sig value, has to be less than this in order for it to be significant. So number A is not true. B is true. This may be significant crap. I don't know what that's about, but we're not going to pick that one. And this probability stuff probably will be significant. That's the same thing. So the only one I see on there is B is the only right answer there. Number 4. The median is, which of the following is true? So we got the first option, the score falling halfway between the lowest and highest scores of a distribution. That is true with a caveat, with an addendum. If your sample is an even number of sample, let's say you got 20 people in the group, when you get to that center of that group, if you put it in cardinal order, order from smallest to largest, you're going to have 2 in the middle. So what you do there is you have to add them and divide by 2. But that's, again, I think this is going to be a curveball. The score point below which half of the cases fall. So which one of these is true? The score falling halfway between the lowest and highest in the distribution, that would be true if you had an odd number of data points. Again, if you have an odd number of data points, one of them will be in the direct center, but that's not true for everybody. That's not true if you got an even number. The score point which half the cases fall. That's a more believable answer because it doesn't tell you that you're picking one number, right? One score. It's a score point, which could be the average of the 2 in the middle. So this is the only one that's true that I can tell. 2. That's probably the right answer. All right, moving on. What scale of measurement? By that they mean, is it a nominal variable, continuous variable, a ratio variable, or an ordinal variable? We do not use interval variables because they're evil, so don't use those. We know that right off the bat. So party affiliation, that puts people in groups. That makes it a nominal, right? Bam. Number 6, standard deviation of population is the square root of the population's variance. That is true. That is true. B is false, and the rest of those are false. So number 6 is A. This is weird. Why are they giving you this on a statistics test? But let me show you how to work that bad boy real quick. You got to remember your college algebra again here. So 2 to the negative 3 is the same as 1 over 2 to the positive 3. Remember that? You move it up or down across a fraction line, you have to change the sign of the exponent, which is 1 over 8, which is 0.125. So there's your answer, right? All right, number 8. If the probability of type 1 error is 0.05, probability of type 2 error, you don't know. None of these are right. You can't be determined, right? You don't know. They are related, but not, you don't add one to the other. It doesn't work that way. So there's number 8. And number 9, which of the following is a parameter? Remember, parameters are from populations, and they are measured with Greek letters. And that is a Greek letter, and that is the only one. Hey, get out of there. That is the only one that's a parameter. So 9 is A, and that's a little sigma. All right, number 10, a z-score is given, a distribution is 2. Wait a minute, a ski-score, okay, so you got a z-score of 2. If the mean of the distribution is 40 and the equivalent raw score is, well, you would break out your z-score formula, but I think I see something already. There's something missing, right? So a z-score, remember this formula, is the individual piece of data from your data set. Some people just call that X, but I just call it XI, minus the data set's mean divided by the standard deviation. So we get a z-score, right? Let's break it down over here. We get 2 equals, we get the mean. But you know what? We're missing the standard deviation. So therefore, this is the right answer. You cannot determine it because you don't know the standard deviation. All right, so again, number 11, scale of measurement. Is it nominal variable, continuous variable, or a ratio variable. Okay, ratio and continuous are the same thing. So, SPSS calls it scale. So it is a regular counting number, or is it a categorical variable, which is nominal, or is it a leveling variable? The time it took a lab animal to learn something. So scored in seconds, that's obviously a ratio variable. There's that one. All right, number 12. Independent t-test. The IV has to be blank and the DV has to be blank. Okay. So the IV has to have two and only two groups. So it's not that one. It's not that one. So dichotomous, that's what that means, is a categorical variable with only two groups. And the DV has to be not ordinal. If it was ordinal, that would be a different kind of test. So interval or ratio, that's the main thing. So remember this. Independent t-test has two groups. That's your IV. Even though it's got two groups, it's one IV. It's a grouping IV. So one IV with two groups, and the DV has to be continuous or ratio or scale. Okay, number 13. The standard deviation of a sampling distribution. So that means you're picking a sample from a population. Which of the following is true? Increases as sample size increases. Not necessarily. Sometimes yes, sometimes no. So that's a no. Increases as the mean of the population increases. Nah. The standard deviations, they have something to do with the mean, but it's not that kind of relationship. So it's not B. C, increases as the standard deviation of the population increases. That is true, right? So remember, standard deviation of sampling distribution is the population standard deviation divided by the square root of the sample size. So if this top number increases, then the sampling distribution is going to increase as well. So that's the answer to that is C. All right, 14. We have a median of 25 and the mean of 30. Right off the bat is you should realize that these are not normal. In a normal distribution, the median and the mean should be relatively the same number. These things are not close. And I always forget the rule. This is kind of a silly one. It's pure memorization as far as I'm concerned. So it looks like, so if we had something like this, and the graph kind of looked like, I'm just doing this by memory here, so it's going to look something like this, right? So the median is down here, right? That's the median, and then the mean is somewhere over here. I think that's what it is. So it looks like it's skewed to the right, positively skewed, right? The tail part. I'm going with this. Don't quote me on that. The answers are down in the bottom. But this, I hate these questions, right? So pure memorization. Just remember this. If the median is less than the mean, it's skewed to the right, and vice versa. If the median is greater than the mean, it's going to be skewed to the left, or negatively skewed. Okay, moving on. Number 15. So at a job fair, a person asks about the wages that most of the employees receive, right? Do they get modest or poor salaries? And just a few people get real big ones? So if this prospective employee walked away from the booth thinking that the salary she would receive would be larger than she could actually expect, it might be because the recruiters use which of the following central tendencies, measures of central tendencies, to convince her in that way. So in other words, they're using statistics to kind of lie. So in other words, which statistic from these guys might misinform the prospective employee? I would probably go with the mean, right? So example, you could have 10 people from the company. 9 of them could work in the lower divisions and not be making a whole lot of money. But the 10th one could be like a vice president or something who's bringing in bank, right? So let's say the average, the 9 people are making, $30,000 a year, but the vice president's making, $300,000 a year. So if you add that in and the average of those, it's going to make everybody look like they make about $100,000 a year. So that has to be the right answer. Median, no, that's the one in the middle. Mode, that's the most frequently no, and range has nothing to do with it. So I'm going with mean here. Number 16. So the normal curve, the bell curve, they're unimodal. It means they got one hump. They're symmetrical, and they are, right? They are, if you cut a line right down the middle, it would be a mirror reflection on both sides. Asymptotic, all that means is that the graphs of the curve will approach the x-axis but never touch it. That is a calculus term, and that is true. So all of these are all true. Okay, so that's my answer here. Next, 17. A basic aim of statistical inference. Inference means you're going to run a test, right? That's all that means. And I wish that stupid thing would stop that. Is to form a conclusion of which of the following is true. Results from a sample based on results of a population. That's kind of weirded kind of strangely, but that seems true to me. Results in a random sample based on results. That seems true too. And that word random makes it more true because it has to be randomly picked. Results in a population based on results in a sample. Dang, this is just a wording question. Results in population based on a study of based on a study of that. Okay, this one is not true. So in other words, basically, you take data from a sample, you try to prove that it's true for the population. It's called generalizability. And as far as I'm concerned, A, B, and C all basically say the same thing. No, it's not C either. So it's either A or B, and I'm going to pick B because it's got the word random in it. So that's my guess, but again, check the answers. Okay, number 18. In a standard normal distribution, the proportion cases of Z is 0 and Z of +1 is approximately. This is the empirical rule. And there it is. So again, in a normal data set, the empirical rule states that roughly 2/3 or 68% of your data should fall between the mean plus or minus 1 standard deviation. 95% of your data should be between the mean and plus or minus 2 standard deviations, and most of your data, 99.7, should fall between the mean and 3 standard deviations. So we are looking at 1 standard deviation here. Let's draw a picture. So here's our probability, and I'll stretch it out so we can do some writing here. Kind of looks like that. Okay, so there's the mean, right? The mean of a standardized population is 0. 1 standard deviation, -1 standard deviation, 2, 3, and it goes out to infinity both ways, but we stop at 3 because we're lazy. Oops, that's a 2 and that's a 3. All right, so we're going to use the 1 standard deviation rule because that's this one. So if you think about it, between the mean minus 1 standard deviation, the mean plus 1 standard deviation, that's 68%. But she only wants the +1, right? So we only want +1 here. So we're only talking about half of 68%, which is going to be, what is that, 34%. That's your answer right there, 0.34. That's your right answer. Okay, so next question. Again with the algebra. All right, let's do this one. What is the equivalent of this? All right, going to break out the algebra. So A minus B equals C. So I'm going to check to see if this one's right. I'm going to put a minus A on both sides. And it's right, these two cancel out. So it leaves me with minus B equals C minus A. And that's the right one. And the rest of these are not right. Number 20, a researcher does a study to see if a new treatment produces a different score on a quantitative outcome, let's pretend it's depression, than an old treatment. So what we're looking at here is let's just pretend that the first treatment is drug A and the second treatment is drug B, or it could be a different therapy type A and a different therapy type B. But again, we're trying to see if there's a difference in the quantitative outcome variable, which we're going to call depression. So the following the treatment, the outcome is collected. What hypothesis is being tested? All right. That they have 2 sample means? Hold on a second. I'm sick of this shit. Okay. That's not right. That's the alternative hypothesis. Remember, we're always testing the null. We're always testing the null hypothesis. And the null states that the means are not different, which is the same as the means are equal. So this is correct. But I'm looking down here, and it looks like D is a better correct because it is talking about the population means. The populations represented by the two sample means have equal means. That is the big null. So I'm going to say this is the right one, and number D. But C is wrong too. Again, we're not testing if they have different means. We're trying to prove that the means are not the same. All right. 21. When do researchers use confidence intervals? So A, to determine the range of the results given likelihood. The word is range. That's the trigger word. I think that's the right one. B, to determine a numerical result that is most likely to occur. No, that's not right. So it has to be A. 22. Researchers were interested in the effect of new treatment on depression. Aren't we all? At the end of the new therapy, they had subjects complete the Beck inventory to assess their treatment. Okay, this use of the BDI is an example of what? It is a DV, right? So they're trying to see if the treatment worked. And so their depression scores are measured by the BDI. So that makes it a DV. And it's the operational definition of this DV. So that has to be the right answer. The other ones are all crazy wrong. All right, 23. Type 2 error. Remember, a type 2 error is when you do not reject the null, and you should have. So it's not A. That's a type 1 error. It looks like it's going to be type this one. False null hypothesis is retained. In other words, the null was wrong, but it was not rejected. This is the right answer. All right, here we go. When beta, that's a capital B, Greek letter beta, when beta is 0.05, remember, beta is your probability of making a type 2 error, which is failing to reject an incorrect null, right? So that's what that is. And we can calculate the power once we know the beta. Power equals 1 minus beta. I'll say that again. Power equals 1 minus beta. So 1 minus beta is 0.05, so the right answer is that. Shkabam. Alrighty, number 25. Just whipping right along here. Hold on. Dun, dun. The smaller the alpha level, and they're talking about the critical alpha, at which a result is statistically significant. So we're switching, just pretend we're going from a 0.05 critical alpha down to a 0.01. What does that mean? The less the probability of making a type 1 error. That is true, right? That's what your 5.05 means. That's your probability that you're going to make a type 1 error. So if you drop that from 0.05 to 0.01, that's the right answer. And the rest of them are wrong, right? 26. Type 1 error. What is a type 1 error? That means you reject the null hypothesis when the null is actually true. So that's that one, right? And a true null hypothesis, which means there's no difference, no relationship, no nothing, was actually right, but you rejected it. And again, an error isn't a mistake made by your calculations. It just means that you got a weird sample, which is always possible, right? Always possible. Oh, look, another algebra question. All right, I'm going to do this one in my head. So, let's see, if we do minus 10 from both sides, we get 15x equals 90, and we divide by 15. 90 divided by 15 is 6. Ta-da. All right, 28. We will more readily detect the difference between the means of two populations when alpha is smaller. Now that makes it harder to detect a difference. Beta is larger. No, that's not it either. The two-tailed test is employed. No, that's not it. N is larger. Yeah, that has to be the answer, right? When your sample size increases, it becomes easier, I guess is a friendly word. Easier to see a difference between the mean population. So I'm going with this one. And oh, look at that, a 4th grade question. So 1/3 is 2/6, 1/2 is 3/6, 2 plus 3 is 5 on top, 6 on the bottom. There's your answer. Use a calculator. Okay, number 3, 30. Which statement is false? The t-distribution and the standard normal distribution of the z-score are alike in that both are, yep, they're both symmetrical. I don't know what that means. It has the same standard deviation? That doesn't make any sense. Have the same mean? That doesn't make any sense. What the chuck? All of these are true. I'm going to have to just go with A. I'm going to go check that real quick. Please hold. All right, the answer says that all of these are true. And again, I'm not agreeing with this. That makes no sense to me. So what is the t-distribution and the z-distribution have the same standard deviation? Was that 1? That's news to me. Have the same mean? That makes no sense. Unless you're talking about 0 as a standardized mean. Again, I didn't read that book, so I'm moving on to 31. So the mean distribution is 75 and the median is 72. If 20 points are subtracted from each score, the mean will be altered by how much? Now, let's pick one. Let's pick a little tiny sample. So let's say we got one score of 100, one score of 50. We add them together, we get an average of 75, right? Bam. Now, let's subtract 20 from 100 and 20 from 50. So that's 80 plus 30. Add them together, that's 110 divided by 2. That's 55. So the mean went down by 20 points. So the new mean would be 75 minus 20, which is 55. Okay. Next question is a range question. So the high number is 92 and the low number is 51. The range is simply the highest number, the highest score, minus the lowest number, which is 51. So it looks like, what, 41? That's your answer. And then 33. All right, good old Bob got a score 60 on a depression scale, but the average is 45 and the standard deviation is 5. Good. And then he took an anxiety test. He got 95 with the mean of 90 and a standard deviation of 12. Which of the following tests would indicate which two tests Bob's scored higher? Which of the two tests Bob scored higher on? Z-score. Boom, that's the answer. And I'm going to do them in my head real quick. So Z-score. So his score 60 minus the mean of 45 is 15 divided by 5 is 3. So he got a Z-score 3 on the depression scale, which is kind of high. He's really depressed. Now anxiety. So we take his score 95, minus 90 is 5. 5 divided by 12 is a lot smaller than 3. So he did much worse on the depression scale. So in other words, he's far more depressed than he is anxious. Next. All right, some calculus. So this little thing here tells us to, that Greek E, that's called the, I think that's a capital sigma. Looks like the E, right, that one. Boom. That means add them all up. And the X is everybody in the data set. So we're going to add them all up first. So 2 plus 4 is 6. And then, because it's outside the parentheses, we square 6. So the answer is 36. Okay, 35. In a normal distribution, scores with the mean of 70, standard deviation of 5, approximately 95% of the scores will fall between which range? That is the empirical rule again. 95% is the mean plus or minus 2 standard deviations. So 2 times 5 is 10. So the low number is going to be 70 minus 10, which is 60. The high number is going to be 70 plus 10, which is 80. And there's your answer right there. Moving on up, 36. The statistical hypothesis to be tested is called the null. Remember, you always test the null. It's the only thing you test is the null hypothesis, which is very boring, right? It says no difference, no relationship, no nothing. That's what the null states, and you're trying to show that that's not true. All right. Population is to complete as sample is to fractional. All right. So population is everybody, everything that could possibly be in that group, and a sample is a part of that population. So it's a fraction of the population. Okay. 38. The probability that the Giants winning the division in their baseball is 0.2. What is the probability that the Giants would win the division this year and next year? So probabilities, which haven't been tested on in a long time, if it's an and, you multiply, and if it's an or, you add. So this question is, what is the probability that the Giants will win this division and next division? So you're going to multiply 0.2 times 0.2, which we all know is 0.5. 0.04. Don't forget the decimal rules. 0.04 as a fraction is 1/25. That's your answer. All right, 39. When alpha is assigned to a very small value, let's pretend 0.001, we can be more certain of our conclusions, whatever the circumstances. That sounds true. Okay, A sounds true. There's a greater risk of rejecting the null when it's true. That is not true. We should use a two-tailed test is not true. We may overlook real. No, that's not true. So it's got to be A. And it's the only one that I think is true. And 40, is that the last one? Yahoo. In general, for parametric tests of numeric variables, parametric just means they use the means and standard deviations. Degrees of freedom is most closely related to the sample size. Right? Degrees of freedom is the sample size minus the number of groups, but that has to be the answer. And that's it. So let me scroll through the answers real quick if you want to look through them. All right, I hope this helps. MGZ.